Right, I'm going to talk about the reactivity series, which is to do with the elements that are metallic. The way it works, and I'm going to show you a diagram at the end, but in the meantime I'm going to show you other things, is that at the top of the reactivity series, the metals are more reactive. They form positive ions more easily, that is, they become positively charged, they give up electrons to other atoms more easily. They are corroded or tarnished more easily, they go rusty or whatever more easily. They need more energy to be extracted from their ores, from the minerals that they're found in, and they are also stronger reducing agents. In other words, they will bear the opposite to oxidizing agents. It starts with cesium, rubidium, potassium, sodium, lithium, barium, strontium, calcium, magnesium, aluminium, titanium, manganese, zinc, chromium, iron, cadmium, cobalt, nickel, tin, lead, antimony, bismuth, copper, mercury, silver, gold, platinum. Right, I'm going to show you examples of some of these. I can't show you an example of cesium or rubidium, but I can show you an example of a potassium compound. This is potassium hydroxide. I can't touch it because it's too reactive. That's the strongest, most reactive element that's in large quantities in this house, I would say. It's obviously well combined with that. It's a very alkaline substance and so forth. Next along, we've got sodium. This is sodium chloride, table salt. That's in the form of a compound, slightly less reactive than potassium. Next one along is lithium, which I can't show you because I don't have a bipolar disorder. So I don't have that medicine around, or maybe I do, but I don't know. Anyway, next one along is barium. Barium is used in barium enemas and barium swallows as a contrast medium for X-rays, but it's not in its pure form again. Notice there's a theme here. There's no pure forms of these metals in ordinary circumstances because they combine so readily with other elements. They are hard to separate. Next one along is strontium, well known from the village of Strontian in Scotland. And next one is calcium, which is of course the element, metal element found in calcium phosphate, which is what teeth are made of and bones as well. Also other things like calcium carbonate, as is chalk and so forth. Okay, next one along, magnesium, as used in magnesium flares. In other words, it oxidizes very easily. All of those can only be extracted by electrolysis, by passing electric current through them, which separates them. You can't be extracted by ordinary chemical means. Okay. The first lot, that's cesium to calcium, all react with water. Cesium causes explosions in water. Rubidium is similar. Potassium catches fire in water. Sodium catches fire in water. Lithium fizzes in water. Barium, strontium and calcium, again, fizz in water. This is going to be a long video, I'm sorry about this. Okay, the next one along is aluminium. Now, aluminium is interesting because it was initially a precious metal. It's thought that in Roman times, the Emperor Tiberius came across somebody who had extracted aluminium from clay, and he had him put to death because it would have damaged the value of silver. In the 19th century, it was more expensive than gold because of the technique used to extract it. And in the 1880s, the whole oil process was perfected, which made it a lot cheaper. So, the next one along is titanium, which is this. Okay, they're all going to look like shiny, boring things because that's what most metals look like, unfortunately. Not very interesting in a way. Titanium reacts with concentrated mineral acid like sulfuric acid and hydrochloric acid. And it's extracted by something called the Kroll process. If it's ever perfected, some other method is perfected of extracting it, it will become extremely cheap because it's a very common metal. At the moment, it's expensive enough for it to be appropriate to make jewellery out of. Okay, next one along, manganese. Manganese. Oh, magnesium. By the way, magnesium is in this chlorophyll. The green pigment in plants is based around magnesium. Okay. Next one along, zinc. Manganese, zinc, chromium. This is chrome plated. It's usually only used as a plating, although it is also used as a mordant for dyes. So that's the next one down. Next one down again, iron. You can see some rust on there to show that it is still quite readily corroded. But you can also get stainless steel, which is mainly iron, which has that in it. Okay. Further down, of course, aluminium. There's some aluminium, and it's strange to think that that would have been worth more than gold a couple of 100 years ago. So, you know, we're rich. Of course we're not. Okay. Next one along, what do we got? Cadmium. Cadmium's very poisonous. It's used in red dyes, but it's not really sort of the kind of thing that you want to have around. Cobalt. Cobalt is a bright blue, forms bright blue compounds because it's a transition metal, and transition metals tend to form coloured compounds. And is an essential element for life because it's part of vitamin B12. Okay, next one along, nickel. Cutlery tends to be nickel plated. It's also very common for nickel to be the cause of allergies. Okay, so there you got your nickel. Next one along is tin. Oh yeah, I've invented a magic teleportation device. I didn't tell you about that. Yeah, this is not actually tin. This is a tin, which is tin plated on the inside. And the reason for that is that tin is very unreactive. The significance of aluminium, by the way, is that it's not safe to use with acidic things like tomatoes, vinegar and so forth, because if you do that, it will react with it and be pulled into the food, and aluminium is implicated as a cause of Alzheimer's disease in some people, although it may be to do with membranes, but I won't go there at the moment. Okay, so we've got down to there. The next one along is lead, which is very heavy. Lead is in the same group as tin, and this is a piece of lead piping, which I haven't murdered anyone with. Where have we got to then? Next one along, antimony. Bismuth. Antimony, I haven't really got much to say about that. Bismuth is the next one. Bismuth is used as an antacid, and that's it really. It's interesting because it tends to contract when you heat it. It's one of the few elements that freezes as it expands. Another one is water, another substance that freezes when it expands, but that's actually very unusual. Next one along is copper. Now, I haven't actually got any exposed copper, but copper's a very good conductor, and it's sort of a semi-noble metal. It's not very willing to combine. It's an orangey red thing, but it goes green because it does corrode again. Next one along, mercury. Here's my spig for measuring blood pressure. I'm going to try and show you the mercury now. There we go. Yeah, here we are. Mercury is a liquid metal and also quite toxic in a similar way to lead being toxic. So there it is. That's probably as close as I want to get to it because it's not very safe. Heaven forfend if that ever breaks. Okay, next one along, silver. I have got some silver, but I can't find it at the moment. It tarnishes, but again, you know, not very reactive. Next one along again, gold. Everyone knows what gold looks like, and obviously we haven't got any because it's expensive. And finally, the final one along is platinum. Platinum hardly reacts with anything at all. Also has a very high melting point and is quite precious. Very, very expensive stuff. So, now to divide those up, you have the first lot, cesium, rubidium, potassium, sodium, lithium, barium, strontium, calcium. Those all react with water, sometimes very violently, and are extracted by electrolysis. Magnesium reacts with acids. Aluminium reacts with acids, and it covers itself in a coat of corrosion, so it actually protects itself. Next one along, titanium reacts with concentrated mineral acids, and then magnesium, zinc, chromium, iron, cadmium, cobalt, nickel, tin, and lead react with acid and tend to be smelted with coke because the carbon in the coke combines with them more readily than what they're already combined with, which is often sulfur or oxygen. And then finally, the last lot can actually be found in pure form in nature, and those are Antimony, bismuth, well actually some of them can't, but anyway, after antimony and bismuth they start to get more common as in their original form. Antimony, bismuth, copper, mercury, silver, gold and platinum. Copper can be found native. Mercury is usually found in the form of cinnabar, which is mercury sulfide. Silver can be found native, although it tends to tarnish quite easily. Gold basically never tarnishes. And platinum never tarnishes either, and is very dense indeed. So there you go, and I'm about to show you the periodic table and a list from top to bottom, and you can pause it and there'll be sort of details on that, okay? This has been a really long video, but I think, you know, it's necessary to make it quite long, I'm afraid. So there you go.